So in the last lecture we have studied this change of scale property. Now this is the continuation of this topic. Here the first few results you should know. By applying change of scale property, one can easily derive these results, that is e power at cos, suppose I am writing here at, or suppose in general if we consider cos bt. If I write, see the formula goes like this: s minus a, s minus a square plus b square. So you know that Laplace transform of cos bt, Laplace transform of cos bt is what? S by a square plus b square. Okay, now if you apply the change of scale property, that is e power at cos bt, so immediately here s minus a, here s minus a square plus b square, that is nothing but this result. Okay, so similarly Laplace transform of e power at sin bt, if you find this result, so this will be here, see, b by s square plus b square, but here because of this term it will become s minus a square plus b square. It's a direct application of change of scale property. Okay, similarly one can derive the hyperbolic function as well. Okay, so Laplace transform of e power at, suppose sine hyperbolic bt, so you know that formula, that here b by s square minus b square, so s minus a square minus b square, this will be the formula. Okay, with the hyperbolic function. Suppose if I write here Laplace transform of e power at multiplied with t power n, so you know that t power n means gamma n plus 1 by s power n plus 1. So here because of this term s minus a power n plus 1. Okay, so these are due to change of scale property. Now we can move to the next property of Laplace transform. So here you can see next one, it is next property, that is Laplace transform of derivatives, Laplace transform of derivatives. So here you can see, suppose let fs is equals to Laplace of ft, then see Laplace of f dash t, it is nothing but s fs minus f of 0. Okay, similarly, see, if you want the proof for this direct definition, you can apply proof. Here I'm just giving you the outline of the proof. If anyone interested, you can go through this. Laplace of f dash t I want, so integral 0 to infinity e power minus st f dash t dt. Okay, now see here, if you apply integration by parts, immediately you will get e power st into integration of f dash t, that will become ft with the limit infinity here 0, minus integral 0 to infinity derivative of this term will give you minus s time e power minus st, minus minus here you have plus, so s e power minus st, and integration of f dash, this term will give you ft dt. Okay, now once you have this one, so immediately if you put the upper and lower limit, so first term will become 0 because e power minus infinity it is present, so first part 0, second part, from the second part you will get minus f of 0 plus s integral 0 to infinity e power minus st ft dt. So this term, it is nothing but again Laplace transform of ft, which is nothing but fs. So you are getting f0 plus s fs. This is the formula. Okay. Now similarly, one can have Laplace transform of f double dash, and the formula goes like this: a square fs minus s f of 0 minus f dash 0. Okay, so similar, just like the same manner, you can prove this second formula as well. So likewise, if one extend this formula, then Laplace of f power nth derivative, usually for our practice purpose these two formulas are sufficient. Okay, now f nth power, if you want this formula, that is s power n f of s minus s power n minus 1 f of 0 minus s power n minus 2 f dash 0. Likewise, it will continue up to f power n minus 1th derivative at 0. Okay, so this set of formulas you should know. Okay, so primarily we consider these two formulas. Okay, so now we can have application of these formulas as well. In the subsequent part you will find it. Now you should remember this formula. Now next I can give you one question here related to this concept. Let's go to the next slide. So here you can write this question: given that Laplace transform of sine root over t, it is root pi by 2s power 3 by 2 e power minus 1 by 4s. Okay, so Laplace of sine square root of t, it is given as this. Then show that Laplace of cos root over t by root over t, that is given by pi by s power half e power minus 1 by 4s. Okay, this is the question. See, it looks like a giant problem, but see, Laplace of sine root over t, no need to find it, it is already given in the question. Okay, it is something like this. Okay, then show that Laplace of cos root over t divided by root over t, the value is given like this. Okay, so we can take, let ft, it is given by cos root over t by root over t. Now you can just observe one thing, that if you find suppose if I am writing sine root over t, okay, suppose let gt is equals to sine root over t. So what will be g dash t? You can find that g dash t, it is nothing but cos root over t by 2 times root over t. Okay, fine. Now here, from here, if you apply Laplace here, if you apply Laplace of g dash t, it is given by Laplace of cos root over t by 2 root over t. It is an application of that previous understanding. So here we can apply that formula, that is s Laplace of gt minus g of 0, here 1 by 2 Laplace of cos root over t by root over t. Now here you can see s into Laplace of g of t, okay, that means Laplace of sine root over t minus g0. So from here you can derive g0, it is 0, so you can put 0, half Laplace of cos root over t by root over t. So from here, if you further do the calculation, that is s into Laplace of sine root over t, it is already given, root pi by 2 into s power 3 by 2 e power minus 1 by 4s. Here already you had half, so Laplace of cos root over t by root over t. Now from here you can directly get the answer, that is Laplace of cos root over t by root over t. You can cross multiply here, so here 2 cancels, so here s and here s power 3 by 2, so immediately you can have root pi, here root s into e power minus 1 by 4s. This is nothing but pi by s whole power half into e power minus 1 by 4s. This is the required answer. So it was a little tricky question, but it is nothing but the application of that previous understanding. Okay, so likewise we can solve this type of questions as well. Now Laplace transform of the derivative we understood. Now Laplace transform of integral. Next result, it is also very important result. Laplace transform of integrals. So again, let Laplace transform of ft, it is given as fs, then Laplace of this one 0 to t fu du, this is given by fs by s, provided s is greater than 0. Okay, so Laplace of this integral 0 to t fu du, that is given by fs by s. If you are interested, you can always do the proof. Now see, this formula, it has its own extended version. You can note down here, Laplace of integral, suppose 0 to t, likewise n times, suppose 0 to t ft dt. If you have this one, so here this is n times integral, that is given by fs by s power n. Okay, next formula, it is differentiation of transforms, that is basically multiplication by t. So in that case, this result, it states that, suppose if Laplace of ft, it is fs, then Laplace of t f of t, it is given by minus dds of fs. So if you extend this formula, then the generalized version, it is t power n ft, it is given by minus 1 power n nth derivative. Here you have this one. Okay, this is the generalized form of this formula. So it is the most frequent used form, and you can note down this formula as well. Here this is the generalized formula. This is nothing but multiplication with t. So now we can consider one question related to this. Suppose, write down this problem. Let find Laplace transform of t sine at, this function. Okay, see the solution. So here basically let the function ft is what, sine at. So you know that fs is what, fs is s by s square plus s square. Now as per this question, tft, you want to find this, so immediately what you need to do, minus, apply this first formula, dds of this one, a by s square plus s square. So if you do the differentiation, so you'll be getting 2as by s square plus s square whole square. So this is the final answer. So likewise we can have, suppose This was first question. Suppose if I write second question, that find Laplace of t e power minus 2t sine t. So for this second question, if you want to solve this second one, so what you have, see ft function, suppose e power minus 2t sine t. Okay, so you know that Laplace of sine t is what, 1 by a square plus a square. Now Laplace of e power minus 2t sine t, what will be this, by change of scale property, 1 by s plus 2 square plus 1. Okay, now this is nothing but Laplace of ft, so that means this is fs is this one. So Laplace of what, t, this ft. So you simply do the derivative of this fs, this quantity fs. Okay, so this is how we can directly solve the question by applying this formula. Okay, now next, another very important formula or result, you can say, this is the integration of transform. Integration of transform. Okay, now previously what we had, multiplication with t. Okay, now here it will be the division with t for the same case. Okay, suppose if Laplace of ft, it is fs, then what you have, see Laplace of ft by t, if I write this one, that is given by integral s to infinity f u du. Okay, f u du, this is very important result. Now we can have one question based on this idea. Now see, one problem we can consider here, find Laplace transform of e power minus at by minus e power minus bt by t. Okay, so suppose this is question number 1. See the solution. So here, suppose ft function is what, e power minus at minus e power minus bt. So you know that fs, here fs will be 1 by s plus a minus 1 by s plus b. So from here, Laplace of this ft by t, this is the question. So this is nothing but, as per that formula, s to infinity fu du. So if you take this, so what will be that, s to infinity 1 by u plus a minus u plus b du. Okay, so if you do the integration, you will be getting log u plus a minus log u plus b. So if you apply the formula of logarithm, it becomes u plus a plus divided by u plus b infinity, here you have s. Okay, so here log, see this first part you can write 1 by 1 plus a by u plus 1 plus b by u minus the second part log, that is s plus a s plus b. Okay, so this first part, as u tends to infinity, the first part as u tends to infinity. For the second part already we put here u equals to s. So for this first part, log 1 will be there, that is nothing but 0. So from this second part, if you just simplify it, so you will be getting minus log this quantity. So use the property of logarithm, that is nothing but s plus b by s plus a. Okay, so the Laplace transform, so from here what you got, Laplace transform of e power minus at minus e power minus bt by t, that is log s plus b by s plus a, correct. So here you can observe few important thing, like for example, remark, if I put a equals to 0, if I put a equals to 0, and suppose if I put a equals to 0 and suppose b is equals to, suppose any particular quantity, if I want to put, suppose b is equals to, or suppose here b is equals to 0, if you are putting, so basically 0 divided by 0 you are getting, so here, and b is equals to 0, so if you put here, so Laplace transform of what, e power 0 means 1 minus 1 by t, so here log what, s by s you are getting, okay. So here Laplace transform of 0 is what, log 1, so what you are getting, you are getting 0, okay. So one beautiful remark you can find from here. Now likewise, if I consider another question, you can try this question. Suppose question number 2, here you can have another problem, like find Laplace transform of cos at minus cos bt by t. Okay, so now next form or next result, which is very important. We are moving to next slide. This is called heavy side unit function or unit step function, okay. So the function of the form u t minus a is equals to 0 if t is less than a and 1 when t is greater than a. This is called unit step function. So if you want to draw the graph of this function, so it looks like this. Suppose this is t axis, this is your ut function. So suppose here t equals to a, okay. So up to this the function it is 0, and suddenly at this t equals to a, after this it becomes this line, okay. And that is here, this is one line, okay. So this is one line. Now this is called unit step function. See, you can see the sudden jump here, okay. So here the Laplace transform of unit step function, okay, Laplace transform of unit step function, it is given by, write down, Laplace transform of u t minus a, it is, see here, what is the function here given, integral 0 to infinity e power minus st, the function is ft, suppose, okay, dt. Now here see 0 to a e power minus st, 0 to a the value it is 0 dt, plus integral a to infinity the value it is e power minus st, here what is the value, 1 dt, okay. So first part will give you 0, second part integrals a to infinity e power minus st dt. So if you do the calculation, what will be the value, e power minus st by minus a to infinity, put upper and lower limit, immediately you will get e power minus as by s. So for this case what will be the Laplace transform of unit step function? Laplace transform of unit step function, it is ut minus a, it is e power minus as by s. Okay, now note one thing, that if a is equals to 0, then Laplace of ut, which is nothing but 1 by s. Okay, so this Laplace of ut, and this ut, it is what, see, 0 when t less than 0 and 1 when t greater than 0. A is equals to 0 you are taking. So basically this is nothing but ut is equals to 1 function. Okay, for t greater than 0. Obviously t is greater than 0, it is by default in the definition you have. Okay, in the Laplace transform definition you have, so you are considering t as time. Okay, so but you have, see this one, this is nothing but Laplace of 1 is equals to 1 by s. Okay, so like this you have the formula for unit step function. So whenever you have the question from Laplace involving unit step function, so immediately you can either apply this formula or you can break like this, because as per the question you can do the treatment. Okay, now see another important result what I want to state here, say second translation or second shifting theorem. Second shifting or second translation theorem. It states that if Laplace of ft is equals to fs and suppose gt is another function, it is a shifted function, suppose f of t minus a multiplied with u t minus a, that means as per the nature of u function this will become 0 when t less than a, and f of t minus a unit step function multiplied when t is greater than a. This is the nature. Okay, suppose a function it is given of this form. Okay, then Laplace transform of gt, here you can see Heaviside unit step function we applied here. Okay, so this gt function, it becomes Laplace transform of f of t minus a multiplied with u t minus a, that is equal with e power minus as fs. Just note it down, this thing. Okay, this is very vital formula. All right, so now this formula, if you want the proof, always you can do it. Okay, now a generalized version of this formula you have. Okay, generalized version, so note down this generalized version as well. So here the note you can write. So if ft is given as, suppose f1t, f2t, like this, suppose fn minus 1t, fn t, here you have the interval like this. Suppose this is for 0 less than t less than a1, for a1 less than t less than a2. Okay, like this. Here suppose a n minus 2 less than t less than a n minus 1, and here for t greater than a n minus 1. Suppose this type of setup you have. a function it is given. Okay, now that means suppose if you want to draw this function, so it is not necessary that 0 to a1 the function behaves like f1. Suppose this is f1 function f1. Okay, a1 to a2, suppose this is the function f2. Okay, suppose a2 to a3, suppose this is the function. Okay, that is f3. Likewise you have the functions graph. Okay, so here you can just tally that sufficient condition was piecewise continuity. Okay, that is sufficient, okay, to have Laplace transform. Now see here in this case Laplace transform of this function if you want to find, so this will be f1t. Okay, this function. Okay, so separately what you can do, see, just let me take this function. See, separately you can write like this: 0 to a1 e power minus st f1t dt plus a1 a2 e power minus st f2t dt. Okay, like that your treatment should be there. Okay, fine. Now this setup, it is also very you can say important when you are going to solve questions. Okay, now with respect to this unit step function, another important thing you should note from here, that this function it is given in this way. Okay, this is one representation. Another representation for this function, it is ft is equals to f1t plus, here you can see f2t minus f1t multiplied with ut minus a1 plus, likewise it will continue the last term f of nt minus f of n minus 1t ut minus a n minus 1. Okay, this is a standard representation for this type of function. Suppose a function it is defined like this, then immediately you can take help of this form as well. Okay, so this form you should keep in mind. Now we can have another problem. Suppose let ft is equals to e power minus t when 0 less than t less than 3, 0 when t greater than 3. Okay, write, the question is write ft in terms of unit step function and then find Laplace transform. Okay, so the solution for this question, see, ft it is given in this form, it is e power minus t when 0 less than t less than 3, 0 when t greater than 3. This is the given form. So now here you can identify, suppose f1t it is e power minus t and f2t suppose it is 0, then the function ft it can be written as, see, f1, what was that form, f1 plus f2t minus f1t, what will write, ut minus a means 3 here. So f1 means what, e power minus t plus f2 means 0 minus e power minus t ut minus 3. So what you have, e power minus t minus e power minus t ut minus 3. Now what you have, e power minus t, here 1 minus u t minus 3. So Laplace transform, if you apply Laplace here, so this Laplace transform of ft, this is nothing but Laplace transform of e power minus t minus Laplace transform of e power minus t ut minus 3. So for that, 1 by s plus 1, this is by standard formula, and here what you have, see, Laplace transform of what, this part, Laplace transform of this part. Now Laplace transform of e power minus t u t minus 3, this term, how we'll calculate this? For that, just go back to the previous slide and see Laplace transform of this one, Laplace transform of a function, okay, t minus a u t minus a, it is given by this. Now see here it is multiplied with the unit step function. So here what will be that value? So Laplace transform of e power minus t. So we know that u Laplace transform of u t minus 3 is what? E power minus as, 3s by s, okay, and multiplied with this. So by first shifting theorem, what will be this quantity? E power minus 3 s minus of minus 1, that is 1 by s plus 1. So this value you can immediately put, that is e power minus 3 s plus 1 by s plus 1. This will be the final answer. Okay, so we have this idea now. So Laplace transform of ft function, that is you can write Laplace transform of ft. Ft function was what? E power minus t multiplied with e power, what was that? E power minus t multiplied with unit step function. Actually this was the function, okay. So this is given by 1 by, if you this part, if you consider this part, that is e power minus 3 s plus 1 by s plus 1, and Laplace transform of e power minus t, it is from here 1 by s plus 1. Okay, so here you have this idea. Likewise, you can have different questions involving this unit step function. So another question I am giving here. Suppose find Laplace transform of gt where 0 less than t less than pi by 2, and here you have sin t greater than pi by 2. Okay, so here you can see first work will be to express this equation in terms of unit step function. That means solution. If we go for the solution, so first you can write down this function gt of this form, that is f of t minus pi by 2 multiplied with u of t minus pi by 2. That is nothing but, if you expand this, so 0 when 0 less than t less than pi by 2, and what you have here f function, that is cos t. If I take t minus pi by 2, that is t greater than pi by 2, that means cos t is our ft function, basic idea. Okay, that is ft we have taken as cos t function. Okay, now if we apply Laplace transform of gt function, so Laplace transform of f of t minus pi by 2 u t minus pi by 2. So as per that formula, previous formula, if you just go back to that formula, what you have? This one, e power minus as fs. Okay, so e power minus pi by 2 s fs. Fs is nothing but this from here. So if you calculate fs, so what you will get? Fs means s by s square plus 1. So here you just put s by s square plus 1. So immediately you are getting the answer, s e power minus pi by 2 s by s square plus 1. So that is Laplace transform of gt function. Okay, so you can get the idea that this unit step function or Heaviside unit step function has its own importance while solving Laplace transformation questions. Okay, So I think you got the idea of unit step function, Heaviside unit step function. In the next lecture, we'll be discussing few more topics, and we'll start Dirac delta function, and after that inverse Laplace transformation. Okay, whatever formula we learned, based on that we'll have inverse Laplace transformation that we'll see in our next lecture.